Hi everybody, welcome to another video in Precalculus, section 9.5, rotation of axis, general form of a conic. So let's just first look at what we already have, conic section with standard axis. By that I mean either horizontal or vertical. That's where we have the standard axis. Now, later on we will have the axes that are not horizontal or vertical. But for now, if we look at the equation in this form, wait, don't have to memorize this. We have some x squared, some y squared, and then x, y, and f. What is missing is the x, y terms. Notice what we have here. Actually, what we don't have there is more important, that we have no x, y terms. We have x squared, we have y squared, but we do not have x, y. And that makes it the standard axis. When we have the x, y, there may be the rotation of the axis. Right, now, also A and C are not both equal to 0. If both of them equal to 0, we just have the equation of a line. Now, we will have a parabola if A times C equal to 0, meaning that one of them is equal to 0, right? A times C equal to 0 implies A is equal to 0 or C equal to 0. So if one of them equal to 0, A or C equal to 0, then it is a parabola. But if both of them equal to 0, then of course that's a line. Define an ellipse if A and C greater than 0, meaning they have the same size. So coefficient of them, coefficient of x, y, x1 and y square have the same sign. It will be an ellipse. On a special case, if they are equal, that will be a circle. And if they have the opposite sign, then it will be the hyperbola. Right. So let's quickly just look at this. Coefficient of x1 and y square have the same sign. So that gives us this is an ellipse. Coefficient x squared and y squared here, opposite sign. That will be hyperbola. And here, when we look at this, we don't have x squared, right? So there's no x squared. If we only have either x squared or y squared, that's going to be a parabola. By the way, don't memorize it this way because later on it will get more complicated when there's the xy term. So this only works with the standard axis. But like I said, don't memorize that because we have a more general form than that. Now, what if we have the rotation of axis? What if instead of have, let's say, an ellipse, but not vertical or horizontal, what if it just rotates at an angle? And what will happen? Now, what we have is, originally, there's an x-axis and a y-axis. Now, if those axes rotated, then we will have x prime and y prime. So x1 and y prime will be the new axis. So let's just note this, where we have x prime, x and y will be the own variable or the own axis, own variable. X prime, y prime will be the new variable or new axis. But in terms of relation, how do we relate the old x and the new x, or the new y and the new y? The relation is going to be this. X equal to x prime cosine theta minus y prime sine theta. Y equal to x prime sine theta, y prime cosine theta. And once again, the axis, x-axis and y-axis will be rotated to an angle theta. So x and y, all variable. X prime, y prime will be the new variable. Right, now let's look at this equation. Very simple, x, y equal to 2. Express that in terms of x prime, y prime coordinates. So first, of course, we're going to write down the formula. X prime x equal to x prime cosine of an angle, this time 45 degrees, but just put in general, theta minus y prime sine theta, y equal to x prime sine theta plus y prime cosine theta. We have cosine 45 degrees minus y prime sine of 45 degrees, x prime sine of 45 degrees plus y prime sine of 45 degrees. 45 degrees, either sine or cosine, both of them are square root of 2 over 2. Square 2 over 2, x prime, square 2 over 2, y prime. Right. Now we just substitute into xy equal to 2. Right, x is that square 2 over 2 x prime minus square root of 2 over 2 y prime. Multiply y is this square root of 2 over 2 x prime plus square root of 2 over 2 y prime equal to 2. Now just multiply this out. Square of 2 times square of 2, so that gives us 2 over 4 x prime square. That times that, also 2 over 4 x prime y prime minus that 2 over 4 x prime y prime and minus 2 over 4 y prime square equal to 2. Now when we multiply this out, the middle term cancel out in this case, and we have 2 over 4 x prime square minus 2 over 4 y prime square equal to 2. Of course, multiply, of course, 2 over 4 is 1/2. I should just write 1/2, but let's just multiply 2 on both sides. 2 and if we multiply 2 on both sides, 2 times 2 is 4 divided by 4 is 1, so that cancels out the fraction. So I have x prime square minus y prime square equal to 4, and we actually have to divide back by 4, so we have x prime square divided by 2 square, which is 4, minus y prime square divided by 2 square equal to 1. We need to have 1 on one side, so we have the standard form for a hyperbola. So here I divide by 4. Right. Now let's look at the graph. Originally we have x and y, the old axis, horizontal x, vertical y. Now we rotate 45 degrees, the x becomes the new x. The y becomes the new y. And then in order to graph this in the x prime, y prime coordinates, we go 2 up, 2 down. and 2 left, 2 right. So we will have the box. So we will have the box. So that's how we graph hyperbola, right? And then when we have the box, we will draw the asymptotes. This time the asymptote is the x-axis and the y-axis, the diagonal in that box. And then the hyperbola starts from the vertex approaching to the asymptotes. So that is a hyperbola. So if we rotate, that's going to be on the x-axis. So it's not really vertical, but it is going to be kind of vertical if we look at it that way. Right. So that's simple enough, right? So the point here is, how do we determine the angle of rotation? Well, in the equation in this form, notice that now we have the xy term when b is not equal to 0. When b is not equal to 0, we have the rotation of axis. Because if b equal to 0, then we just have the standard axis. Furthermore, we have the formula: if theta is the angle of rotation, then cotangent of 2 times that angle is equal to a minus c over b. If b equal to 0, divided by 0 is undefined, and when we divide by 0, is undefined. Cotangent of something is undefined. Cotangent is undefined when the angle is equal to 0. So in that case, there is no rotation. Right. So that, with that, we can calculate the angle of rotation. So we go do that. Now let's look at this example. Analyze the equation x squared minus square root of 3xy plus 2y squared minus 2 equal to 0. Actually, this is a typo. So that should be minus 20 equal to 0. I will change it before I post a note online, so that should not be a problem. Right, first we need to determine the angle of rotation. Well, that is the cotangent of 2 times theta equal to a minus b, a minus c over b, this case, this equation, a is 1, coefficient of x squared, b coefficient of xy, negative square of 3, and c is 2. I substitute in here 1 minus 2 divided by square root of 3. So negative 1 square root negative square of 3. Sorry. Divided by negative square root of 3 is 1 over square root of 3. That is cotangent. Well, the calculator doesn't have cotangent, so we're going to use tangent instead. So cotangent of 2 theta turn into tangent of 2 theta. All we need to do is just flip the fraction, square of 3 over 1. And then to get back to the angle, we find the tangent inverse. Make sure that it is in the degree mode. Yep. Tangent inverse of square root of 3. That will be 60 degrees. So the angle is going to be 30 degrees. Next, we will have the old coordinate x and y relate with the new coordinate as that equation. So I'm going to write out x equal to x prime cosine of theta, which is 30 degrees, minus y prime sine of 30 degree, and y will be equal to x prime sine of 30 degree plus y prime cosine of 30 degree. Right. Cosine of 30 degree square of 3 over 2, and sine of 30 degree, that is 1/2, right? So we have square root of 3 over 2 x prime minus y prime sine of 30 degrees 1/2 y prime, that is x. Y is sine of 30 degrees, so 1/2 x prime plus square 3 over 2 y prime. Right, and substitute this into the equation. So we will have, trying to write small, x squared, so this one square 3 over 2 x prime minus 1/2 y prime square, so that is x, minus square root of 3 x y one half x prime square 3 over 2 y plus 2 times y 1/2 x prime square 3 over 2 y prime square minus 2 equal to 0. Minus 20 equal to 0. Right, multiplied square is multiplied by itself. So square 3 over 2 x prime minus 1/2 y prime. Square is multiplied by itself. Square 3 over 2 x prime minus 1/2 y prime. Right, minus square root of 3. I just copy that. 1/2 y prime right, and then 1/2 x prime square 3 over 2 y prime, and then plus 2. Square is multiplied by itself. 1/2 x prime square 3 over 2 y prime multiplied by itself. 1/2 x prime square 3 over 2 y prime minus 20 equal to 0. Now just multiply it out. Square 3 times square 3 is 3 over 2 times 2 is 4. So once again, I'm going to write very small. 3 over 4 x prime square, and multiply that square root of 3 over 4 square 3 over 4 x prime y prime, and minus another square root of 3 over 4 x prime y prime. 1/2 is 1/4 y prime square minus square root of 3. Multiply this out. Square root of 3 over 4 x prime square plus 3 over 4 x prime y prime minus 1 over 4 x prime y prime, and then the last one minus square root of 3 over 4 y prime square, right? And then plus 2 times 1/2, and 1/2 is 1/4 x prime square plus square root of 3 over 4 x prime y prime plus square 3 over 4 x prime y prime plus square 3 times square 3 is 3, 2 times 2 is 4 y prime square minus 20 equal to 0. Right. Now, notice that the middle terms, they are the same, so we can combine the middle terms here. We can combine, and then the other terms combine the middle terms. Right. Now we have 3 over 4 x prime square. Square of 3 and square of 3, make it 2 square of 3 over 4, 2 and 4 cancel out. We have minus 2 minus square root of 3 over 2 x prime y prime and 1 over 4 y prime square. Now, square of 3 times square of 3 is 3 over 4, so that's just minus 3 over 4 x prime square. Three fourths minus 1/4 is 3/4 minus 1/4 is 2/4, which is 1/2. 1/2 times square of 3 minus square of 3 over 2. So 1/2 times square of 3 x prime y prime. And square of 3 times square of 3, that's actually positive. 3 over 4 y prime square. Right, next 2 and 1/4, that's is 1/2 x prime square. Square of 3 times square of 3 and square of 3 make 2 square of 3 over 4. 2 over 3 cancel out, so we have square of 3 over 2 actually cancel with 2. So we just have square root of 3 x prime y prime. 2 and 3/4, 2 and 4 cancel out. We have 3/2 x prime square minus 20 equal to 0. Right, combine like terms. We have the x square here. 3/4 minus 3/4, so that cancel out. One, two, three, 1, 2, 3. And then we have, sorry, this should be a y, right? Yeah. 3/4 and 2 and 4 cancel out is 2, so that should be y. And then we have 1/2. So 3/4 cancel 3/4, 1/2, so we have 1/2 x square. Next, negative square of 3 over 2, negative square of 3 over 2. When they add together, we have negative 2 square of 3 over 2, 2 and 2 cancel. So negative square of 3 plus square of 3, actually all of that cancel out. 1 square root of 3 cancel half, 2 halves of square root of 3. And we left with the y square, 1/4, 3/4, and wait a minute. That multiplied by square of 3. Right. So what is a quarter plus 3/4? Actually 1 plus 3/2. So we have 2 halves, which is 2.5 or 2. Sorry, I just do that by my head, it will be better. Right, minus 20 equal to 0. Of course, to get rid of fraction, multiply everything by 2. We have x squared, x prime square plus 5y prime square equal to 40, but I will write 40 on this side. And finally, to turn into the standard form, I need to divide by 40 because we need 1 on the other side. So I have x prime square over 40 plus y prime square over 8 equal to 1. Yeah. So now we see that this is the graph. The ellipse, it have to rotate 30 degrees, and the equation of the ellipse is going to be that, which is exactly what we have. Right, so straightforward. First we determine the angle rotation, and then we use the rotation of axis formula. The calculation is complicated, but they should cancel out nicely. What we should have is just equation of a conic without rotational, without the mixed x prime y prime. Right, now what, of course, when we do that, we know this is going to be an ellipse. Now, is there a better way when we just look at the equation and tell if it is an ellipse, hyperbola, or parabola? Well, there's a way to do that, very easy. So when we look at the equation x squared plus bx plus cy squared plus dx plus ayf, actually those terms doesn't matter. What it matters is just these three terms. Right, and we have b squared minus 4ac. By the way, does that familiar? Does that look familiar? Well, if you look at quadratic formula, b squared minus 4ac over 2a, actually this, the discriminant is b squared minus 4ac. If that is equal to 0, it is a parabola. If it is less than 0, it is an ellipse. If it is more than 0, it is a hyperbola. By the way, hyper means it's over, right? So it is more than 0. Parabola is equal, and ellipse will be less than that. So it's pretty straightforward. All we need to do is just b squared minus 4ac. So on this one, b squared minus 4ac negative 16 squared minus 4 AC. 16 squared is 256 minus 4 times 5, 20 times 4 is 80. Doesn't matter what it is greater than 0, right? So it's going to be hyper because it's more than 0, hyperbola. Right, this one, b squared minus 4ac, b squared minus 4 ac, a squared 64 minus 64 is equal to 0. If it is equal to 0, it is a parabola. Right. The reason we don't have an ellipse here because we can just look at this equation. If we do b squared minus 4ac negative square of 3 squared minus 4ac, 3 square of 3 square is 3 minus 8. That's less than 0, so that's an ellipse. And we did confirm that by calculation. It's actually an ellipse. Right, so, and remember, I said the first part of the section you don't need to memorize, but this part we need to know. The equation now have the rotation of the axis term. Of course, if this one works, then this certainly works as well, except this one doesn't have the b is equal to 0, but still apply the same way. Right. So in this section we have two things. First, we can determine the angle of rotation is that when we have that angle, we can do this to go from the new axis to the old axis of x prime, y prime, and we do that to eliminate the rotation. Right, now with the rotation. And then also we need to be able to classify ellipse, classify conics from that equation, and we just use the discriminant less than 0 ellipse, more than 0 parabola, equal to 0 parabola. So again, two things: how do we classify a conics using that, and then two, how do we find the angle of rotation, and what do we use to calculate the rotation. Right. So with that, I end section 9.5 here. As always, thank you for watching, and see you in another video in calculus.